Hello everybody, I'm Lieutenant Timothy Mueller, and I'm going to be the instructor in another installment of the Damage Control Assistant Senior Enlisted curriculum. Today we're going to be talking about weight shifts, Chapter 2, Lesson 3, and how to calculate the movement of the center of gravity when we impart a weight shift on a vessel. Now the equation to find how far the center of gravity moves when you do a weight shift is fairly simple. It's down here at the very bottom. However, I'm going to go through the steps on how to derive it so you can see exactly how we get from one point to another. So let's say we have a system of 3 masses. The original configuration is right here, and you recognize this from Chapter 0, Chapter 1, Chapter 2, and you're going to see it very frequently more often. We have R1 equals 1 over total mass times the summation of all the individual moments. Now, let's say we shift a weight. Now we have R2 equals 1 divided by a different mass 2 times the summation of all those. Now we have to kind of relate one equation to another. We know that R2 equals R1 plus some change, which we're going to call delta R. That's what we're going to try and solve for. M2 equals M1. We're not going to be changing the overall displacement of the ship. And we're going to be shifting this first weight. This M1 R1 is going to go M1 R11 to M1 R12. That's just the first state, and that's the second state. And R12 just equals R11, which is the original point, plus D. And D is the distance that we shifted. Now, all we do is we take these equations, the end state and the original state, and we subtract them. We subtract the original from the end state. And then we get this line. Now, I'm not going to go into all the math behind this, but as you can see, the R's cancel out, so we're left with delta R. Then we have 1 over N. We have M1 R11 plus D, and we have M1 R11. The M2 R2 and M3 R3s cancel out. And actually, we're left with this, which will cancel that R11 with all of that. Now, all we're left with is M1 times D, all divided by the total mass of the system, equals delta R. And that's what we have here. We have delta R, which is the change in the coordinate of the center of gravity, equals the mass that we shifted, times D, how far we shifted it, divided by the total mass of the system. Or, if we're going to change it into terms that we use in shift stability, G1, G being the original G, and then G1 being the next G after the weight shift, equals W, which is the weight that we moved, times D, the distance that we moved it, divided by the displacement. Since remember, when we do a weight shift, we don't change the displacement of the vessel overall, so that displacement in the beginning is going to be the same as the displacement at the end, which is what we said right here. Even though it's not necessary to completely understand all the math behind that, it's always good to see how you can mathematically represent one state and then the state of another, and then subtract the two and see exactly what's left to find out the formula on how they've changed. So let's go into a quick example problem and see exactly what kind of information this formula gives us. We have a vessel that draws 2,000 long tons that has an original kg of 5 feet, and we're going to be shifting 3 long tons up 14 feet. It's going to go up 14, not up to 14. And now what's going to be the kg1, the new kg of the vessel? The formula that we talked about earlier, it doesn't give us all the information that we need. It only tells us how far the center of gravity moves. However, it's not that difficult to find out what we need. We know that the new kg is just going to be the old kg plus or minus the change in the center of gravity that we're going to calculate. So kg1 equals kg0 plus gg1, that's what we had mentioned earlier, equals, just substituting the formula in, kg0 plus w times d divided by displacement. Now we have all this information. 3 long tons goes to w, 14 feet goes to d. Displacement is not going to change. We'd already mentioned that in another video. When you have a weight shift, you're not going to change your displacement. So our 2,000 is going to go down there, and we're adding it because we're shifting up 14 feet. If we had a shift down, that d would be negative, and so we'd be subtracting this. Now doing all these calculations, adding to the original kg, we're going to get a kg1 of 5.021 feet. When you do calculations with center of gravity, you're going to get answers that range from the hundredths of a foot to 1 to 2 feet, in some extreme cases, maybe even more. However, if you get an answer of 19 feet, a change in center of gravity of 19 feet, or even in the hundreds, then you might want to check your calculator and make sure that all the buttons and all the order of operations are correct. So this concludes our video on calculating the movement of the center of gravity due to a weight shift. In the next video, I'm going to be talking about how to find a new kg when you have a weight addition or removal. But until then, I'm Lieutenant Timothy Mueller, and I hope you have a great day.